Hi everyone. My name is Vaibhava Lakshmi, and I'm working as an AI and growth lead at GRAIL. And I also do research on AI for healthcare, and I'm genuinely thrilled to be a part of this conference. I would like to start with a simple scenario. So let's say your team builds a de-identification pipeline, your healthcare AI team. So you validate it. Let's say you get an F1 score of 0.97, which is 97 percentage. So your CISO signs it off and your IRB is satisfied. And then you go ahead and ship your system. And then somewhere in your output, a patient with a rare condition in a small town, like admitted in a specific week, is fully re identifiable. Not because your model was bad, because it was doing exactly what it was trained to do. Now take a look at the right side of this slide. Two things are in tension. ML teams optimize for F1 score generally, and HIPAA requires per record guarantees. And the line at the bottom, this is the thesis of everything that I'm about to discuss about. The model is not wrong, the objective is. So let's go ahead and unpack that. Before I make my argument, I would just like to give an overview on what all terms that I would be covering in this session. So let's get started. I'll start with PHI, or protected health information. Anything in a medical record that could identify a specific patient uniquely. Let's say name, date of birth, address, phone number. So these come under the category of protected health information. HIPAA defines exactly 18 such specific categories. Next, let's see what HIPAA is. The US federal law governing patient data privacy. Violations start at $100 per incident and up to 1.9 million per category per year. So it's not a suggestion. Next is DID, or de-identification. Basically, this involves removing PHI so that clinical data can be used for research or AI without exposing patients. The next one is F1 score, the standard accuracy measure for NLP models. 1 is perfect. Then 0.97 means right, it is right like 97% of the time, and 3% of the times it definitely falters. Next one is the NER, or named entity recognition. So this specific task is used by de-identification models. The model reads continuous text and then labels individual words in that text as PHI or non-PHI and removes them. So if you're already familiar with all of these terms, it's amazing. Otherwise, I hope this little introduction helped you with it. So let me just make the 3% feel real as of now, because when people see F1 of 0.97, the instinct is to read it as essentially as perfect. So I want to break that instinct with arithmetic. A mid-sized US health system processes around 500,000 clinical notes per year. So at F1 of about 97%, that 3% error gives you about 15,000 documents per year with at least one missed piece of PHI from one deployment, one hospital, and one single year. So now I can hear the pushback. 15,000 out of 500K is still small, and here is where I need you to shift your mental model. So basically, this is not a spam filter. A spam filter that misses 3% of spam can be annoying, but a de-identification system that misses PHI 3% of the times exposes real patients to real privacy violations. The harm isn't distributed evenly. It's concentrated in specific people, often the most vulnerable ones, the ones with stigmatized conditions, complicated social situations. For them, it is not just the 3%, it is 100%. But then, one more thing I would want to mention is that missed tokens are actually the smaller problem. The deeper issue is that whatever your model was never designed to catch in the very first place. Let's see this. Your model was never actually designed to catch these, not because it was built badly, but because the problem was framed incorrectly from the start. Three failure modes, I'll name them here and go deep on each. The distributional shift, the data your model trained on is not the data it sees in production. The next one is quasi identifiers. Like even after removing every direct identifier using named entity recognition, a document can still describe exactly a single specific person through like a combination of facts or descriptions about that person. It need not be a specific identifier at all. The third one is tokens versus records mismatch. Your model asks, is this word PHI? HIPAA asks, can this record identify a patient? Different questions. Only one is in your loss function. So let's go deep down on each of these. Most de identification models are trained on benchmark datasets. The two you will hear about most are I2B2 from a Harvard Research Initiative, and the next one is MIMIC, a publicly available ICU dataset from Beth Israel Deaconess Medical Center based in Boston. So, excellent datasets there. The field owes a lot of them.
On the left side, whatever you see, that's what your models are trained on actually. Curated, annotated, clean, and institutionally homogeneous. So on the right side, that's what your production system actually sees. Hurried nursing notes.
Full of abbreviations, voice transcribed reports that have literal transcription artifacts and then like phonetic name errors, multi language names. Let's say this has a certain number of other languages, and these could have been unseen while training. So, this can pose a major threat. The fourth one is EHR, copy paste text. So basically, the F1 score your model achieved on I2B2 or MIMIC is valid for that distribution. The moment you deploy to a new institution, a new department, a different patient population, that number is literally aspirational, not actual. So no one has told your compliance officer. The next failure mode, let's say, is quasi identifier. This is the failure mode I want you to really sit with. It has caused every major healthcare privacy breach in the research literature so far. And I would say that current NLP systems are structurally blind to it. So let's look at the three boxes. A rare autoimmune condition affects 1 in 50,000 people, rural zip code, population 300, and then hospitalized in the third week of January. None of these is actually a PHI token. Your NER model correctly leaves all three literally untouched, but F1 stays high. The model did exactly its job. And yet, if you put all these three together, you have described exactly one person, one single person living on this planet. Anyone in that community who knows this can literally identify that person. So, this is what researchers call a quasi identifier. It's non PHI information that becomes identifying in combination. And here's the number I want you to remember. Latanya Sweeney at CMU or Carnegie Mellon showed in 2000 that 87% of Americans can be uniquely identified using just birth date, gender, and 5-digit zip code, not names, not medical records. Three fields that don't appear on HIPAA's list of 18. So the model is not just failing, it was never designed to solve this problem. So the third failure mode is token level versus record level. And this is where the argument actually becomes a systems argument rather than a modeling argument. So on the left, you see your NLP model that processes text word by word. It sees the 45-year-old firefighter from the small town. And for each word, it asks, is this PHI? None of them fire. The model just returns clean. So on the right, the HIPAA asks, can this record identify a patient? Not this word. This record and the sentence, the 45-year-old firefighter from the small town where the mill explosion occurred last spring. Anyone in that region knows exactly who this is. Different questions, only one is in your loss function. The model's loss function, I mean. So you cannot fine tune your way out of this. It's not a, like, say, a data quality problem. It is not a hyperparameter problem. It's a problem formulation mismatch. So, and that requires a different kind of solution actually. So I would like to address the like obvious question head on because I know it's in the chat right now. If NER has all these structural limits, then why not just simply use large language models? Like you could just feed in your data and then get the de-identification done using the large language models. Fair question, but it entirely depends on which LLM we are considering. Let's say commercial LLMs like GPT-4, Claude, or Gemini. A big no. And the reason isn't the model quality, but the reason is that every API call sends a patient data to an external server. That is a HIPAA violation regardless of accuracy. PHI leaves your building. Beyond that, LLM outputs are probabilistic. HIPAA expert determination requires a reproducible, traceable evidence trail, which you cannot produce from a system whose outputs you cannot fully predict. And these and hence the like economics of commercial API pricing don't work at health system scale. Let's say GPT 4.0 that is under consideration. The price limit for its like per token is super high, and patient data is not something that is like scarce or something that is like me whose scale is like medium. It is like extravagant. So for that, using LLMs is not a very good choice, I would say. So let's consider another set of LLMs called the open source on premise LLMs. Let's say we are using Llama 3, Mistral, or even like OpenBio LLM. These run entirely within your infrastructure. Same privacy guarantee as NER. PHI never leaves the building, and they do something NER genuinely cannot. They understand context. An open LLM grasps that the firefighter from the mill explosion town is identifying. NER only sees tokens. So the answer is a hybrid. NER as the deterministic backbone for the 18 safe harbor identifiers. On premise open source LLM as a second pass reviewer for contextual and ambiguous cases. And I want to be precise, the LLM is a heuristic flag for human review, not a compliance guarantee for itself. All within your infrastructure. No PHI leaves your building at all. So in this slide, I would slow down a bit and I would encourage you to screenshot this one if you want to like come back to it later. Each layer does something that the previous one cannot. So that's like the whole point of this. Let's say start with layer one, NER plus on-premise LLM. NER removes the 18 safe harbor identifiers fast and deterministically. The on-premise LLM handles the contextual and ambiguous cases that NER misses. Both run inside your infrastructure. Layer 2 is Quadrant. Quadrant is a vector database. It searches by meaning, not by keywords. We use it two ways, and I want to be precise about both because like conflating them is where most explanations would actually go wrong. Let's say use case A. We store the embeddings of previously flagged re-identification risks and check whether a new clean record is semantically similar to those. This catches known quasi identifier patterns. B. We store embeddings of the entire cleaned corpus and measure how isolated a new record is, how far it sits from its nearest neighbors in meaning space. If it sits in a sparse region, that rarity itself is a risk signal, even if the pattern was never seen before. So, same engine, different logic on top, and critically, neither is a guarantee. Low similarity in quadrant means the record is unfamiliar. Also, if it doesn't mean the record is safe. The third layer is the statistical disclosure plus human review and documentation. So let's say tools like ARX compute population grounded re-identification risk from attribute combinations, and the accuracy of that computation depends on how well your reference population reflects your actual patient population, which you need to calibrate per deployment. Human reviewers examine flagged records, and the output is a documented artifact. What was removed, what was tested, what was flagged, why the risk is demonstrably very small. So, this documented artifact is what HIPAA expert determination actually requires, not an F1 score. It's an argument. So, quickly on the legal side, because I think a lot of ML teams have a vague sense of HIPAA without having read the specific language. Two pathways under the 45 CFR section 164.514. Safe harbor. It removes all 18 identifier categories, deterministic, auditable, a solid foundation. But notice what it doesn't cover: quasi identifiers, combinations of non PHI attributes, novel attack surfaces. It is a checklist, and checklists don't anticipate what hasn't happened yet. The next one is expert determination. A qualified expert, a statistician, or privacy professional certifies that re identification risk is very small. This requires a population grounded probability estimate, a documented evidence trail, a human expert who can defend the judgment. So, the bottom line on this slide: HIPAA is concerned with something different than what F1 measures. That gap is what this entire talk has been about. So, three takeaways that I would like to mention. One, high F1 does not mean HIPAA compliant. F1 scores measure token level accuracy on a test set. HIPAA requires a guarantee that no individual record can re identify a patient. A model can score perfectly on one and fail completely on the another. The next one, quasi identifiers are your real attack surface. The model was never designed to catch this. You cannot fine tune your way out of a wrong objective. The fix is a system that thinks at the record level, not the token level. 3. Compliance is a system property and a documented argument. So, let's say NER for direct identifiers, on premise LLM for context, quadrant for known patterns and statistical rarity, disclosure tools for population grounded risk, human review and documentation for HIPAA. No single layer is the specific answer in this. The model is not wrong, the objective is. So, thank you so much for having me. And I would love to take any questions based on this. And